So what about an alternative? If we can't be absolutely certain that a visual inspection gives us a true reflection of the blood lactate response to incremental exercise, are there other approaches? Well, one of the options that was put forward was the onset of blood lactate accumulation. This is OBLA, originally proposed by Mader in 1980. And I just want to just ring that bell in your mind, which is if you go back earlier on in this class where I was showing you all the terms and definitions, and the authors had got what they call the second threshold. And remember that I said that their definition of a second threshold is not LT2. It's this higher point which they are defining as this transition between heavy and severe. They've got OBLA. They've got OBLA. Okay, so this is where the confusion really lies. OBLA is a proxy indicator of what we've been defining, which is the transition from steady state to this kind of starting to get into this non-steady state exercise, moderate into heavy based exercise. So OBLA is associated with what we call the 4 millimole turn point. And it's basically defined as a fixed blood lactate concentration. So irrespective of what happens, the author said, well, look, visual inspection is clearly probably not that scientific, and you can't really rely on it. It doesn't necessarily have good test-retest reliability, as we can see in more recent data. And they looked across a range of responses in athletes and non-athletes as well, and actually said, well, actually, if we look at this and we look at the visual response, it's coming in pretty close to 4 millimole when this transition starts to occur. So they said, well, look, to get around this, just use a fixed concentration of 4 millimoles. And it seemed to be that their data identified this kind of linear-like response, so this kind of steady state condition up to about 4 millimole, and then the loss of linearity, the point really where the rate of appearance of lactate started to exceed its rate of disappearance, at and around 4 millimoles. And the range they've got is around about 3.4 to about 4.8 millimole. So it's 4 millimole sits within that kind of mid range. And you kind of make an argument for this. And if we look at this data published in 1982 from Sogin and Jacobs, it perhaps reinforces this. And they write this: endurance exercise performance is strongly correlated to this exercise intensity. They're talking about this transition. Many groups express this variable as the exercise intensity corresponding to a blood lactate concentration at 4 millimole per litre. And this intensity has been referred to as the onset of blood lactate accumulation. And so it became a very, very popular way of identifying this aerobic capacity. But I'm sure there is already kind of an alarm bell going off in your mind going, hold on, this sounds slightly odd. How can we use a fixed concentration for everybody and that concentration be the same for everybody? Well, here's some data from Gush and published in 2004, and it's just an idealized response. And so what they've done is they've plotted their treadmill speeds and their blood lactate concentration, and this kind of conforms to what I said earlier on in terms of a curve fit. This is why you've got to be careful doing curve fits. It doesn't fit the data, and this really shows you kind of the variability in the data response that you can see. But interestingly, they actually got a workload which hit the 4 millimole concentration. The issue is, what happens if I don't get a workload that hits the 4 millimole concentration? Let me show you. So this is the data from our laboratory. So we're going to find 4 millimoles. 4 millimole is probably around about here. So what we'll do is we'll just mark this up a little bit, just to see if we can make this kind of work for us, so that we can get a sense of what I'm referring to. So imagine this is about 4 millimole. I'm going to draw roughly a straight line. I'm not very good using these kind of pens. So straight line across, there's 4 millimole. So where does it intersect the curve? If I'm going to put a curve in here. Obviously, it'd be better doing curves than doing lines, and it seems to intersect this point here, but we don't know that that point is genuine. So we're kind of going to make a suggestion it's about 250, which is way higher actually than what we actually show for this point, which is amazingly is at 210, which is actually what we identified the point as when we did, for example, a visual inspection. Okay, so we start to get into this issue that we're using a generalized approach for individualized data. How can we use something which is fixed? It clearly doesn't represent necessarily what is going on. The other thing to think about is that when we train somebody, and they do endurance training, the amount of lactate that we see in the circulation, so that is the difference between the appearance and disappearance, reduces. Because you become more efficient in two things. One, you become more efficient in lactate production, so fundamentally less lactate is being produced for muscle contraction. And secondly, the ability to consume lactate is also enhanced. So the net result is the lactate concentration reduces. But the 4 millimole doesn't ever reflect that response. It simply is a fixed lactate concentration. Irrespective of those changes, it occurs. And the second thing is, in incredibly well-trained endurance athletes, you will be very lucky to get them to 4 millimoles at the end of an incremental test. You know, elite swimmers at the end of incremental tests in the pool have been reported not to get higher than 4 millimoles at the end of a test. So they've gone way past this transition point. So it kind of does suggest to us that as an alternate, this may not be fit for purpose. And in fact, if we look then at the test-retest on this, so again using Bland-Altman plots, the same thing exists as we saw earlier with the visual inspection. And in fact, one could argue it's almost identical. It's around about the same difference of about 2.7 kilometers an hour with enormous spread in the data. So this kind of reflects the high degree of variability in lactate responses, and therefore the high degree in variability in the predictability of the 4 millimole response in identifying the transition from moderate to heavy intensity exercise, the kind of conventional steady state to the onset of where we're starting to get into this less or steady state orientated exercise.